I hope you all had a wonderful holidays and also revised the lessons and you didn't miss any lessons. And I hope you already revised the previous sessions, Newton's law and the moments. Uh, I will give a brief briefing in regarding the equilibrium, and we'll start from there and we'll continue the topic today. I think you can see my you can see the screen properly. Okay, okay, thank you. Uh, I'll give you briefing about equilibrium, the last class we were talking. When an object is in equilibrium, this is regarding forces equilibrium, the net or the resultant force is zero, which means the forces in x direction, the net forces in x direction will be zero, the sum of forces in y direction will be zero. So in equilibrium, in forces equilibrium, there will be two situations. First one is static equilibrium and the second one is dynamic equilibrium. Static means it is at rest or stationary. The object is not moving, but it is in equilibrium. A simple example, please use your school ID, it will be easy for me. Okay, a simple example, just imagine you are standing on a horizontal straight floor. So what are the forces acting? Your weight is acting downwards always, and normal contact force between your legs and the surface. It is always perpendicular to the surface. Okay. Now, in this situation, if you consider it as objects, then it is in equilibrium, right? Only two forces acting. So forces in y direction should be zero. Then W, the weight is equals to the normal contact force. Okay. What is dynamic equilibrium? Dynamic means moving. Something is moving, an object is moving, but it is in equilibrium. How it can be? According to Newton's second law, you know F equals to ma. There, F is a resultant force, not just force. It should be net force or the resultant force. When you are describing Newton's second law, it should be resultant force. It is equals to mass times the acceleration of the object. Okay. If if F is zero, then acceleration of the object also zero. Now, how to describe an object is moving and acceleration also zero? Then only one condition is there. Object is moving in constant velocity. When an object is moving in constant velocity, acceleration of the object is zero. Okay. A simple example, a vehicle is moving in constant velocity. Example for dynamic equilibrium. The forces in y direction, the sum of forces in y direction will be zero, and sum of forces in x direction will be zero. So when an object is in equilibrium, you can explain both static equilibrium and dynamic equilibrium. Either it can be in stationary condition or it can be moving and moving in constant velocity. Okay. Principle of moments. In each and every moment's problem you're gonna solve, you have to use this principle. This is like, if you don't know this principle, like, you can't solve. This is also under equilibrium. It states that total of all moments trying to turn an object in clockwise direction is equal to the total of all the moments trying to turn the object in anti-clockwise direction. Then it will be in rotational equilibrium. So what are the conditions for rotational equilibrium? When an object in rotational equilibrium, the moments in clockwise direction will be equal to the moments in anti-clockwise direction. The anti-clockwise term, sometimes they will use counterclockwise. Those both terms are same, anti-clockwise or counterclockwise direction. So what are the key points? When an object is in rotational equilibrium, same as in forces in equilibrium, it will remain stationary. Of course, it can remain stationary. The moments are balanced. Or if it is already rotating, it will rotate at constant speed in the same direction. If the object is rotating and the object is in rotational equilibrium, then it is rotating at constant speed in the same direction. So for rotational equilibrium, you can write an expression, moments in clockwise direction equal to moments in anti-clockwise direction. How to apply now? How to apply this principle? Okay, for simple example, a seesaw. When you are applying this principle, the one thing you have to note, when an object is in rotational equilibrium, take moments about the same point. At this example, a girl and a boy is sitting on the seesaw and it is rotating about point A. Now I have to take uh, moments about point A. If I take moments about point A, what are the clockwise moments? There are two forces acting, the weight of the girl W2 and weight of the boy W1. Now apply the principle. When a system is in rotational equilibrium, now I am taking moments about point A. Moments in clockwise direction. Moments in clockwise direction. What are the moments in clockwise direction? Only one force makes the moment about point A in clockwise direction. If there is another other forces making clockwise moments, we have to sum it up. So in this example, W2 into R2. What is the definition of moment? The force into the perpendicular distance from the pivoted point to the line of the action of the force. The perpendicular distance, yes. Here, the distance, perpendicular distance is given. If the force is acting at an angle, you have to find the perpendicular distance first. Then you can find the moment about any point. Okay. Clockwise moment here, W2 into R2, and anticlockwise moment. Anticlockwise moment is W2, W1, the weight of the boy, into the length R1. So this is how you have to apply. Let's see how to apply in a question. There are some questions you have to solve. I cannot solve all the questions within this class, so please take a photograph so you can solve it and send me the answers so we can discuss. I will solve some selected questions. Question number 3 and 4 here. Question number 5. Okay, let's try to solve this question. In the figure shown, a uniform beam is resting on two supports. First of all, they are mentioning a uniform beam. Then the center of gravity is at the middle of the beam, right? The mass is uniformly distributed, uniform beam. Then resting on two supports. This is simple supports, not fixed. Simple supports. Okay. Find the normal contact force by each support. Okay. First of all, you can see the distance from center of gravity to the supports are different. Then, of course, the normal contact forces are, the magnitude of the normal contact forces are different, right? Okay. In this question, I will show how to use both forces, equilibrium, and moments, how to apply it. Okay. Before that, you have to identify what are the forces. You can see right now the weight is acting. Then there are two more forces acting. What are those forces? Normal contact force at point A and point B. It is perpendicular to the contacting surface. It is perpendicular to the beam at this situation. Okay. First of all, weight is acting 70 newtons and R1 is normal contact force at point A and R2 is the normal contact force at point B. Okay. Now you have identified all the forces. Now the system is in equilibrium. When the system is in equilibrium, you can use both forces equilibrium and the moments. Okay, I'll show how to use both. Okay, the beam is in equilibrium, then net force or the resultant force is zero. All the forces are balanced. Then you can get a expression from the first resultant force equating zero. Then moments moment of all the forces acting on the beam is zero. What's that mean? It means clockwise moments equal to anti-clockwise moments. You can choose either point A or point B. You choose any point, take moments, and find any of the normal contact force, and you can choose another point and you can find another normal contact force. Here I will show how to use both principles. Okay, considering vertical forces. I am considering upward forces as positive. Then what are the upward forces here? Normal contact force R1, normal contact force R2. Those two are positive forces. Then the weight is acting downwards. It is R1 plus R2 minus 70 equals to 0 because object is in equilibrium. Then rearrange it. R1 plus R2 equals to 0. This equation alone you can't find R1 or R2 because there are two unknowns, right? You have to find out either R1 or R2 first. Okay. Now you have the option to use moments, right? Because object is in equilibrium, you can choose either point A or point B, take moments. Okay. If I am choosing point A, the moment from R1, is there any moment from R1? No, because it is on the pivoted point. There is no perpendicular distance. So if I am taking moments about point A, there is no moments from R1. There is no perpendicular distance. Then only two forces to worry. The force, the weight, and R2, the normal contact at point B. Okay. Can I choose point B? Yes, of course you can choose point B, take moments. Then if you are choosing point B, then R2, from R2 there is no moments, only moments from 70 newtons, the weight, and R1, the normal contact at point A. Here I am choosing point A as my pivoted point and taking moments about point A. Okay. Take moments about point A. You can take moments about point B also. There is nothing wrong there. Then clockwise moments equal to anti-clockwise moments. What is the clockwise moments at point A? About point A. Point A, okay. Weight is acting. Any other clockwise moments? No. Weight into the perpendicular distance, 70 into 2. The perpendicular distance is 2. 70 into 2 equals to, what are the anticlockwise moments? R2 is making anticlockwise moments about point A, then R2 into the distance, the perpendicular distance is 5 meters. Now you can find R2 here. Rearrange the equation and find R2. It is 28 newtons. Then substitute R2 value in the previous equation. Find R1 42. Okay. Now, without considering vertical forces, if anyone taking moments at point A, find R2. Again, considering moments at point B, find R1. Yes, they can do it. That also correct. So they'll get the same answer. You can choose only moments. I'll take moments at point A. I can find R2. Yes, find R2. Then moments about point B, find R1. That also correct. I'm just showing how to use both forces in equilibrium and the moments, how to use both. Okay. Question number one, I showed you there. Also, we'll discuss. I think we have time to continue. Yes. Question number one, I showed you. Here, the question says at point P, it is pivoted, it is fixed, and the beam is in equilibrium, and uh, point Q, a force is acting perpendicular to the beam, and the beam is uniform beam, and weight is acting downwards. The length of the beam is PQ length is 3 meters. Then the length of P to center of gravity is 1.5, half of PQ. Okay. Uh, the angle to the horizontal is 50 degrees. And one more important point. In this question, they are not asking, but you have to note down at a pivoted point. Okay. A simply supported and pivoted point, there is a difference. Here, we don't know the Normal contact force, the and magnitude and the direction of the normal contact at point P, because it is a pivoted point. It is not just resting at the point. Here, if we don't know a magnitude and the direction of a force, you can always show the components of the force. Okay? You just show that you just select one direction. This is Rx, the X component, and Ry, Y component. You find it Rx and Ry separately and find the resultant there, that is the normal contact of point P. Okay. In this question, they are not asking that. I'm just, for more information, I'm telling you, if they ask, you have to do the question like that. When a point is pivoted, we do not know the direction and the magnitude of the reaction force. Here, I'm just telling here at point P. In this situation, you can indicate X and Y components separately, find it separately, and find the resultant force somewhere, somewhere here. It's going through point P. Okay, just extra information to the question. Now we will move to the question. What they're asking? The question they're asking, find the magnitude of force F at point Q. Okay, to find magnitude of F, what is the best option? The best option is the beam is in equilibrium, then use moments. Now, when you are taking moments, the next question is which point I am going to choose. Okay, you can choose point P, center of gravity, or point Q. Which point? Just think now. I have to find F and which point I am going to choose. If I choose point Q, can I find the force F? No, because if I take moments about point Q, so the force F also on the point. So there's no moment about point Q from the force F. So point Q is not an option. So if I choose center of gravity, where weight is acting, no, because I don't know the reaction force at point P. I can't choose the center of gravity also. The best option is choose point P. Point P, if you choose point P, then you don't no need to worry about the reaction force at point P, because that from reaction force there's no moment about point P, right? Okay. Now you chose the point. Now see what are the forces from point P. Weight is acting clockwise in clockwise direction, and F force is acting anti-clockwise direction. A moment is about point P. Now for force F, it is acting perpendicular to the beam. You don't want to find the distance because you know PQ distance, it is the perpendicular distance. But weight is acting downwards, you have to find the perpendicular distance. This angle is known. To find F, we can take moments about point P, then reaction force at point P does not contribute a moment. Okay. Now find the, the perpendicular distance from point P to the weight here. This is the perpendicular distance. So this length is known 1.5 meters from P to center of gravity. Then towards the angle, this length is 1.5 cos 50. Always just draw a simple diagram. If you can't find the length directly, then use the trigonometry. You know one length, which cos, sine, cos or tan I have to use. Which length I have to find, then you will find out cos, sine or tan. You have to use it. Okay. Just draw a simple diagram before finding the length. Okay. 1.5 cos 50. Okay. Now you know the perpendicular distance to it. Now apply moments. Clockwise moments equals to counterclockwise moments. Then the mass of the beam is 8 kg. Then weight of the beam is 8 into 9.81 into this is 1.5 cos 50 is the perpendicular distance from point P equal to force F into 3. 3 is length of PQ. It is the perpendicular distance from P to this force F. Rearrange the equation and find the magnitude of the force F. It is 25.2. Please redo the question and find the magnitude of the force and check whether my answers are correct. And please send me the answers for previous questions. I told you, showed you this question number 2, question number 3, 4, and you can practice and choose a point, the correct point, and take moments. We have one more topic to cover in this moment. So, uh, I think we can complete it tomorrow. We have the class is up to 12, 10, right? Anyone?
Yes, sir.
Okay. I think I have to stop now. From class B, who gonna send me the attendance? All 55 students, I think.
Yeah, I can do it.
Okay, thank you, Naif. And class E, I'm not familiar about the students. Please, anyone?
I will send.
Okay. Is it Rafa?
Yes.
Okay. Thank you, Rafa. And thank you, students. We'll meet tomorrow. Thank you all.